Hello student, welcome to our second lesson. Under this we are going to look at determination of refractive index. We start with the definition of refractive index neta. Now this one is defined as the ratio of sine of angle of incidence I to the sine of angle of refraction R for a ray that is passing from one medium to the other. We are going to consider a ray that is traveling from medium 1 to medium 2 as shown in this diagram. Now, if you look at this ray, this is what we are calling the incident ray, the angle of incidence. Then we have refracted ray and the angle of refraction, R. Then it is traveling from medium 1 to medium 2. Now, for these two medium, you find that the refractive index is equals to sine of I over sine of R. Now, and this is read as refractive index of medium 2 with respect to medium 1 and is written as this. Refractive index of medium 2 with respect to medium 1 and is given by sine of I over sine of R. Now, we know that there is a principle that we call reversibility of light. And this principle states that the path of light can be reversed. In other words, if you have a ray that is traveling from medium 2 to medium 1 along the same path, it will make the same angles. That is, the principle of reversibility of light states that the paths of light can be reversed. We have now reversed the path. Instead of coming from medium 1 to medium 2, now the ray of light is now coming from medium 2 to medium 1. But the path will remain the same. But now this R will be the angle of incident and this I will be the angle of refraction. Remember, the angles remain. So using this, we can be able now to get the refractive index of this medium. It will be sine of R, this one, divided by sine of I. And this will be read as refractive index of medium 1 with respect to medium 2. Note that it is now the opposite of this. This was refractive index of medium 2 with respect to 1. And that was sine I over sine R. But here now we have refractive index of medium 1 with respect to medium 2, which is sine of R divided by sine of I. In this case, R is now the angle of incidence. That is why now we are starting with sine R. Now from there, we have that sine I over sine R is equals to refractive index of medium 2 with respect to medium 1. But for you to get sine of I over sine of R, it is the same as the reciprocal of 1 sine of R over sine of I. Or that is 1 over sine R over sine I. But we know that this part, is the refractive index of medium 1 with respect to medium 2. This part. Therefore, we can say that the refractive index of medium 2 with respect to medium 1 is the reciprocal of refractive index of medium 1 with respect to medium 2. Now, if the refractive index for a ray of light passing from air to glass is given by refractive index of glass with respect to air, and the refractive index for a ray passing from glass to air is represented as refractive index of air with respect to glass, then the principle, or by the principle of reversibility, we have that the refractive index of air with respect to glass is equals to 1 over the refractive index of glass with respect to air. Remember, we have just used this concept, that the refractive index of medium 2 with respect to medium 1 is equals to 1 over refractive index of medium 1 with respect to medium 2. In our case here, medium 1 or medium 2 is air and medium 1 is glass. Note that when we are talking of absolute refractive index, This is the refractive index of a material with respect to the vacuum. Remember, all these ones, we are referring to two medium, either air and glass or glass and water. But now when you take the second medium to be vacuum, then whatever you're going to get will be absolute refractive index. And a vacuum has a refractive index of 1. That is 1.00. Then from there we can look at examples. We have that a ray of light passes through air into a certain transparent material. If the angle of incidence and angle of refraction are 60 degrees and 35 degrees respectively, calculate the refractive index of the material. In here we are given the angle I and angle R. So we proceed as follows. We have this as our diagram. This is 60 degrees, this is 35 degrees. This is air, this is transparent material. So refractive index by definition is equals to sine I over sine R. Therefore, we replace or we substitute our values will be sine 60 degrees divided by sine 35. And when you key this in your calculator, you find that the refractive index is 1.510. We move to example 2. Given that the refractive index of glass is 1.5, calculate the angle of incidence for a ray of light traveling from air to glass if the angle of refraction is 10 degrees. Now in here we are given the refractive index and the angle of refraction. So we proceed as follows. This is what we have. We have angle I. This is what we are looking for. We have the angle of refraction. We are also given the refractive index. So we have that the refractive index by definition is sine I over sine R. So therefore 1.5 is equals to sine I over sine 10, and that will give us that the angle of incident I will be the sine inverse of 1.5 multiplied by sine of 10 degrees. And when you key this in your calculator, you find that the angle is 15.09 degrees. This will be the sine of our angle of incidence, or this will be the angle of incidence actually. Then from there, we move to our third example. Calculate the refractive index for light traveling from glass to air, given that the refractive index of glass with respect to air is 1.572. We proceed as follows. We have seen that the refractive index of air with respect to glass is the same as 1 over refractive index of glass with respect to air. So because we are given this refractive index, you just get the reciprocal. And when you do that, you find that the refractive index of air with respect to glass is 0.6361. Then we have the fourth example. The refractive index for a ray of light traveling from air to water is 4/3, while that for a ray that is traveling from air to glass is 3/2. What is the refractive index for a ray traveling from glass to water? We proceed as follows. Now, to get the refractive index of water to glass, we need to multiply the refractive index of air to glass multiplied by the refractive index of water to air, or with respect to air. But we know that the refractive index of air with respect to glass is the reciprocal of the refractive index of glass with respect to air. Therefore, this value where we have the refractive index of air with respect to glass, you write this reciprocal. Therefore, after writing and then you multiply by this, you will find that by substituting the value, this will be, remember what is given here is the refractive index of glass with respect to air. And what we want here is the refractive index of air with respect to glass. So we write the reciprocal of this that is given. So the reciprocal will be 1/3/2. And then you multiply by what is given, the refractive index of water with respect to air. So 1/3/2 is the same as 2/3. And then you multiply by 4/3, you get that 2 times 4, you get 8, 3 times 3, you get 9. So the refractive index of water with respect to grass will be 8/9. From there, we have the assignment. The assignment is testing what we have just learned. So take your time and attempt your assignment. Thank you, and let us meet in our next lesson.